Okay, dear students, in this playlist we are studying revision or introduction to the functions. So already we have studied logarithmic function, inverse function, algebraic function. In trigonometric function we have studied about the angles and their measurements. Now today's lecture will see definition of these trigonometric ratios. So these trigonometric ratios, trigonometric functions are defined in by two methods. One is in a right angle triangle. So trigonometric ratios are defined only in right angled triangle. So trigonometric ratios. So trigonometric ratios defined in right angled triangle. So if you consider suppose right angle triangle ABC, so if you consider this angle theta, now opposite to A, opposite to B, this is C, by Pythagoras this is under root A square plus B square. So in this right angle triangle, tan theta plus ratio sin theta. Sin theta is equal to this with respect to theta. This is opposite side. This is adjacent side, and this is hypotenuse. We short will write HYPT hypotenuse. So sin theta is equal to A upon C. Cos theta is equal to adjacent side upon hypotenuse B upon C. Tan theta is equal to opposite side upon adjacent side. Now reciprocal ratios, the reciprocal of tan is cot theta. So B upon A, or we can write 1 upon tan theta. Again tan means sin upon cos theta. This we can write A upon C divided by B upon C. So that is sin theta upon cos theta. So 1 upon tan theta or cos theta upon sin theta. Then sec theta is the reciprocal of cos, so C upon V. So 1 upon cos theta. And cosec theta is equal to C upon A, hypotenuse upon opposite side. So 1 upon sin theta. So these are the 6 trigonometric functions or the trigonometric ratios which are defined in right angle triangle. Now other method to define the trigonometric ratios, that is in unit standard circle. So in unit standard circle, so you know the standard circle, the center at origin, that is the standard circle. Equation of standard circle with center at origin and radius A, suppose x you are r, x square plus y square is equal to r square. Unit means radius will consider for that circle 1. So radius r is equal to 1. Suppose if you consider P general point xy. Suppose this is the theta. If we draw the perpendicular at M, now this x and this is y. So sin theta is equal to get y upon 1. That is the y. So in unit standard circle, sin theta is equal to y coordinate of point, that is coordinate. Cos theta, so you keep this in mind. Cos theta is equal to x upon 1, that is x. So we can write cos theta is equal to x coordinate of point abscissa. So x coordinate is abscissa. So you keep this in mind, sin theta, y coordinate, and cos theta, x coordinate. From this other ratios very easily we find. Now from this concept we can very easily find trigonometric ratios of quadrantal angles. So quadrantal angles, you know, already we have studied this definition in angles. So quadrantal angle means angle in standard position with terminal arm along any one coordinate axis. So we consider this unit standard circle. Now here this x-axis, this is the y-axis, this is negative x-axis, and this is negative axis. This origin O 0 0. Now this is the unit standard circle, radius is 1. So this point will get here 1 0. This point will get 0 1. This point minus 1 and 0. This point is 0 minus 1. Now here angle we are measuring from zero. Theta is equal to here in the standard position to theta is 0. Here we will get theta 90 degree. Here we will get theta 180 degree. Here we will get theta 270 degree, and here again we will get 360 degree. Now you know this sin theta y coordinate and cos theta x coordinate. So sin 0 degree is equal to y coordinate 0, cos 0 degree x coordinate 1, sin 90 degree y coordinate 1, cos 90 degree x coordinate is 0, sin 180 degree 0, and cos 180 degree is minus 1, sin 270 degree minus 1, cos 270 degree is 0, and similarly sin 360 degree is 0 and cos 360 degree is 1. So this for this quadrantal angles, very easily we get the ratios by this definition, which is defined in unit standard circle, that is sin theta y coordinate and cos theta x coordinate. Now next we will study Trigonometric Ratios of spatial angles. So to find the Trigonometric ratios of spatial angles means 30 degree, 45 degree and 60 degree. So very simple method to recall these values. If you are not reminding, you take the numbers 0, 1, 2, 3 and 4 in the sequence. Divide each number by 4. So 0 upon 4, 1 upon 4, 2 upon 4, 3 upon 4, 4 upon 4. So after, and take the square roots. So 0 upon 4 is 0. So root 0, root, you take the roots also, you can take roots. So root 0 is 0. Root 1 upon 4 is 1 half. 1 upon root 2, root 3 by 2 and 1. Now recall the trigonometric ratios of quadrant angles which are defined in standard circle. So cos 0 is 1 and sin 0 is 0. So if we take here sin theta and then theta is equal to 0 degree in sequence 30 degree, 45 degree, 60 degree and 90 degree. 180, 270, 360 from unit standard circle we will get the ratios. So sin 0 is 0, sin 30 1 half, sin 45 1 upon 2, sin 60 root 3 by 2 and sin 90 is 1. Now you know this cos 0 is 1, so this will write the cos theta ratio, and theta is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So cos 0 is 1, cos 30 root 3 by 2, cos 45 1 upon root 2, cos 60 1 half and cos 90 is 0. This is very simple way to remind the trigonometric ratios of the spatial angles. Now you want to keep the values in the mind for this quadrantal angle and special angles in the mind. So we'll prepare the table. What you want to keep in the mind. So theta and ratio. So theta will take 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 180 degree, 270 degree, 360 degree. So these values you want to keep in the mind. Now in the radians, 0, pi by 6. So you know this 30 degree, 30 into pi upon 180, pi by 6. This pi by 4 radians, pi by 3 radians. This 90 means pi by 2, 180 degrees equal to pi radians. This is 3 pi by 2 and this is 2 pi. Now ratio sin theta, cos theta, tan theta is equal to, we know this, sin theta upon cos theta, cot theta 1 upon tan theta, sec theta is equal to, you know this, 1 upon cos theta, cosec theta is equal to 1 upon sin theta. So in short, if you keep these two values in the mind, very easily you will find values of other trigonometric ratios. So sin 0 is 0, sin 30 is 1 half, sin 45 1 upon root 2, sin 60 you know this root 3 by 2, sin 90 is 1, sin 180 is 0, this is minus 1 and 0. Cos 0 is 1, cos 30 root 3 by 2, cos 45 1 upon root 2, cos 60 1 half, cos 90 0, cos 180 minus 1, cos 270 0 and cos 360 is 1. Now tan means sine upon cos. So 0 upon 1, 0. 1 upon root 3 means tan 30 or tan pi by 6 is 1 upon root 3. Tan 45 is 1. Tan 60 or pi by 3 is root 3. Tan 90 1 upon 0 infinity not defined. Tan 180 0 minus infinity 0. Cot means 1 upon 0 infinity root 3 1 upon root 3 1 upon infinity 0 1 upon 0 is infinity but negative axis minus infinity 0 infinity. Sec 1 upon cos 1 upon 1 is 1 which cos sec 0 is also 1. 2 upon root 3 sec pi by 6 2 upon root 3. Sec pi by 4 root 2 sec pi by 3 is 2 infinity minus 1 minus infinity and 1. Cosec means 1 upon sine, so 1 upon infinity 2 root 2 2 upon root 3 1 minus infinity minus 1 and infinity. So these values you want to keep in the mind. By practice automatically we are recording these values. Next for coterminal angles, so trigonometric ratios of coterminal angles are same. So in short, sin 0 degree is equal to sin 360 degree is equal to sin 360 plus 360 to 720 degree. That is equal to sin 0 is 0, so 0. Now if suppose if we consider angle 120 degree in the second quadrant, so this angle is 60 degree and this total angle 180 plus 60, so 240, and this is negative, so minus 240 degree. So sine 120 degree, that is nothing but sine 90 plus 30. Now when 90 is added, ratio changes. In second quadrant, sine is positive, so cos 30, and cos 30 is root 3 by 2. Sine of minus 240 degree, sine of minus theta is minus, so minus sine 240 degree, so that is equal to minus sine 180 plus 60. So that is 180 is 2 into 90, ratio is not changing, minus sine 60 degree. Now for sine, in which quadrant? Second quadrant sine is positive, so plus, and sine 60 is root 3 by 2. So these two angles are co-terminal angles and the ratio is coming same. So sine 120 degree is equal to sine minus 240 degree. Now sine 240, that is difference between these two angles is 360 degree, then that angles are co-terminal angles. So in short, you keep this. When in any angle, integral multiple of 360 is added, the ratio is not changing because that is the co-terminal angle. Now next, we'll understood how we'll find the trigonometric ratios of allied angles. Very important article. So trigonometric ratios of allied angles. So sine n pi by 2 plus or minus theta is equal to, we get plus or minus sine theta or maybe plus or minus cos theta. So if n is e1, so in short, e1 multiple of pi by 2 is added or subtracted to acute angle theta, the ratio is not changing. If n is equal to odd multiple of pi by 2 is added or subtracted to acute angle theta, the ratio changes, that is sign changes to the cos. On the same manner, cos n pi by 2 plus minus theta is equal to plus minus cos theta or plus minus sin theta if n is equal to e1, if n is equal to odd. Tan n pi by 2 plus minus theta is equal to plus minus tan theta if n is equal to e1, that is equal to plus minus cot theta if n is equal to odd. Cot n pi by 2 plus minus theta plus minus cot theta or plus minus tan theta if n is even, if n is odd. Sec n pi by 2 plus minus theta, that is equal to plus minus sec theta or plus minus cosec theta if n is equal to even, if n is equal to odd. Cosec n pi by 2 plus minus theta plus minus cosec theta plus minus sec theta if n is even, if n is equal to odd. Now here, whether the sign is taken plus or minus, For that, for sine, we'll apply rule ASTC. So you know this, in unit standard circle we have defined sine theta y coordinate and cos theta is x coordinate. So you know this here, both the coordinates are positive. Here x negative, y is positive. Second quadrant, third quadrant both are negative. Fourth quadrant x positive and y negative. So this is the first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So for sine apply ASTC to angle n pi by 2 plus or minus theta. Positive angle, first quadrant, theta you always assume here, theta is equal to always you take acute angle. So plus theta first quadrant, minus theta fourth quadrant, and in that n pi 2. So when pi by 2 is added, the quadrant is changed. 1 pi by 2 one quadrant, 2 pi by 2 two quadrants are changing, and so on. So in first quadrant, if angle lies, all the ratios are positive. So you know this ASTC, all positives. Here sine positive, y is positive, sine positive. Here sine and cos negative. So minus minus plus, and tan is sine upon cos. Here x positive is cos positive, and so on. So this concept we'll use whether the sign is taken plus or minus. So now we'll see this, how we'll apply in examples actually. So for example, suppose sine pi by 2 minus theta we consider, suppose. Now theta will take acute angle. So here pi by 2 is 1 into pi by 2, ratio changes cos theta. Now here for sine minus theta, fourth quadrant acute angle, and in that we are adding pi by 2, means angle is coming here. This is the pi by 2 minus theta. Now this is the first quadrant, all ratios are positive, so sine is positive, we get plus sign. Now if we take suppose cos of pi by 2 plus theta, cos of pi by 2 plus theta. Now here pi by 2 multiply factor is 1 or sin theta. Now here angle plus theta, and in that we are adding pi by 2. So second quadrant, here sin is positive, but for angle n pi by 2 plus theta means here pi by 2 plus theta ratio is cos. So in second quadrant cos is negative, we will write minus sin theta. Similarly, suppose if you write sin pi plus theta is equal to, now pi means 2 pi by 2, sin 2 pi by 2 plus theta. Now 2 means even, so even multiple of pi by 2, ratio not changing, sin theta. Now for sin plus theta, acute angle in first quadrant, minus in the fourth quadrant, and in that we are using pi by 2, so pi by 2 pi. So third quadrant, here tan is positive, our ratio is sin, so minus sin theta. Now suppose if you want to find cos 780 degree, so we can write this cos 780, now 360 plus 60 degree. Now 720 means 8 into 90 degree plus 60 degree. Now as per allied angles, 8 means odd multiple, odd of the even multiple, ratio is not changing. So cos 60 degree. Now plus or minus sign. So plus 60 degree means first quadrant, and in that 1, 2, 3, 4. 8 is also coming, co-terminal angle, all positive ratios. So here sign is positive, and cos 60 is this one half. So in this way we can use allied angles to find the trigonometric ratios. Now next we study trigonometric identities. So first three identities. First is sin square theta plus cos square theta is 1. Second identity 1 plus tan square theta is equal to sec square theta. And third identity is 1 plus cot square theta is equal to cosec square theta. So okay, we'll stop here. Next lecture we'll take the next problem.